All right, so President having a problem there. So nobody has any idea about this question.
No, sir.
Okay. All right, let's get this link. Oh, let's get the invitation out then. And then so the length is 17, but most people, some people need to be here now. Mm. So it's in that. All right. Extension load graph for spring is shown. All right. Verse 9. All right. Get some zoom on it so we can get it some clarity here. This is a graph here showing just a regular graph that you get, one like we did get last time. And but in this case, I'm drawing it and asking you to read it. So again, this is something that CXC could ask. And not beyond them to do that, but you plot the graph and I'm asking you things about the graph. So they say when an object is hung from the spring, the length of the spring is 19.2. Again, they told you before that the unstretched length of the spring is this. So this is the original length. So pay attention to that when we're talking about deformation, which is the temporary change in size of an object, or which is elasticity. That's this another name for the behavior. All right. So the object change in size when a force is added to it. So it starts out at 17, and spring, the spring is actually 19.2 here. The question is, what is the extension?
2.2. Same.
2.2. All right. Now the extension is 2.2. Fine. Then let's go. So we're going to find the extension here. So we know where 2 is. So you see, simple the question is also you have 19.2 centimeter. And I guess this is the extension. Well, this is the let's call that final length then. All right. Yeah, point is at 19.2, original length would be 17.0, and you'll end up with 2.2 centimeters as the extension. Extension is the final length minus original length. Then question 9. The extension is 2.2. So the extension is over here on the y-axis. And then, of course, this is the x-axis, so as usual. But we're going to find 2.2 here, and all we need to do is read the graph. All right, read the graph like we are very sensible students, so we can do that. We can say that this is 0. So it's actually 1.1, and this is like 1.2. So the point is that like you're going to have 1.9 here, and so that's 2.1, and then we're going to have 2.2 here. All right. Everybody understand how we read the y-axis over here, the extension?
Yes, sir.
Each of the small marks is actually 0.1. So, you all you need to know is how to count. All right, and you're going all the way up till you reach 1.0, which is the same thing as 1. All right. So anyway, 2.2 is up here. So we're going to draw a line come across, and the question asks, what is the weight of the object? We know that the extension is 2.2. We're going to go from 2.2 to the line, and we're going to come all the way down and see which number this is.
3.0 Newton.
And that's your answer. Simple as that. Any questions here, guys? Because if
No,
here's a
sir.
1, this a 2, this will be 3, this will be 4. So, yeah, that's it.
Yes, sir. It seems easy.
Seem easy. No, I practice like crazy.
So that's their problem.
For true, sir, easy, but they look hard. But sir, would I get you right still? But I guess, would I still get you right?
Right. So remember, you have to sharpen up. This is all of the possible Hooke's last question. By the time we're done, Hooke's law would have come in like nothing. All right. So it have to be something like this, I'm saying. I mean, there's no other way to ask about Hooke's law. So get used to it. Graph, spring, string, anything we can stretch, then you ask about. And it's all about putting masses on it and seeing how it extends. How the length changes. You get a graph, or them draw a graph for you, or them ask you to plot the graph, one way or the other. It works like that. All right, let me just go here. All right. So if everybody familiar with this, or at least understand what's happening here. All right. More practice coming your way though. So hopefully these things might get clear for those who don't understand. But you have to move on. See other types of questions here, guys. Question 4. 2 metal blocks P and Q have identical dimensions. They hang on identical spring balances. All right. So what can be deduced about P and Q? All right. So I guess then let's make this smaller. Okay. Yeah, there you go. There you go. All right.
Sir, it seems like I would probably say A.
You say A. All right. Pay attention to the keywords here. Masses, weight, volume, the keywords here I'm using. All right, so let's see.
Sir, it's A for real.
It's A.
Sir,
The obvious.
sir, probably B, because we probably have equal masses.
No.
All right, let's just go into the question and see if we're understanding what it's saying carefully. 2 metal blocks P and Q have identical dimensions, right? Identical dimension. What does that mean? A block, So it means if the dimension they might same. Identical twins means they in favor. Then if the dimensions are identical, how the volume for different? Volume is the same thing as length times width times height. All right, but see that?
Yes, sir.
Yes, sir.
So if the dimensions are identical, it means whatever P is, Q is the same thing. So the volumes can be different. Yeah. So you know that you can start eliminating now, Then can have different volumes. Then can have different volume. if the dimensions, which are dimension mean length, width, and height. Hope everybody is understanding that. Length, width, and height are the same. Therefore, if these three things are the same, then both objects P and Q have the same volume. Do we
So,
understand that?
Yes, sir.
So I see then, sir.
No.
No.
Another some reach.
There is D.
No, I know if you see say the volume them are the
Yes,
same.
sir. We
All right.
understand.
So that I got eliminate A and it I got eliminate B. But see that?
Yes, sir. We saw.
All right. So all right. So eliminate properly now. It's between C and D. Which one would you choose?
C.
D.
All right.
Sir, may I say D na?
Yes, a D. All right. So all right, we want to, because now that we know the volumes are equal. So yes, the first part is on the same for C and D, but
Sir, D would be more preferable.
equal weight. But then what is weight measured in?
Newton.
KG.
Yeah. Which one are kg? Who say kg? Weight is measured in newtons.
Newton.
Mass is measured in kilograms. Weight is measured in newtons. Go into exam knowing the difference there. All right. Weight is measured in newtons. So P is how many newtons?
2.
2.
2. All right. Q is how many newtons?
3.
Is 2 the same
Yes,
as
I
3?
did then.
Hold on. No, I'm not asking. No. Let's have a gun.
Answer.
Is 2
No,
the same as 3?
No.
All right. So therefore, this gun then also the weight them can be equal. Eliminate. We don't need to know the right answer. We just need to have sense and eliminate. And the key things are hidden in the question. So it's hide and seek for some of the CSEC questions, guys. Seek and you shall find. Knock on the door will be open. All right. So do we understand why D would be the correct answer?
Yes, sir.
Yes, sir.
All
Sir,
right.
can you explain to me how the volume part would come in again, sir?
It is up here. So it was with that. Am I?
Yes, sir.
The identical dimensions. Dimension mean the different parts of the object, which is the length, the width, and the height.
Oh,
You understand? So therefore, if we are talking, if the question mentions volume, they are mentioning the 3 dimensions of the object at once. Okay? So they're combining all of the dimensions of the object, which they tell you were identical for both objects. So it means whatever the dimensions are for P and Q, they will be the same. Hence the word identical. So therefore, the volumes can be different. So that is it. So the volumes are actually the same. And hence, we have to choose one of the options that says equal volumes. All right. And based on the Newton measurement now, it will tell us the weight of the object, which elimination using that will give you a D as the answer. All right. So pay close attention. All right. Now, all right. So any questions here, guys? No.
No,
All
sir.
right. All right. And this will be the last defamation question for tonight, because we need to look at the others. What's this? Number 5. Student adds weights to an elastic card. He measures the length of the card for each weight. He then plots a graph for the result. Okay. Straight there. See if this there's no typo here based on what I'm seeing. Oh yeah, there is a typo. That's question 5. Let's go to this this one and see if there is. Oh no, this is okay. This question is okay. All right. So a student adds weight to elastic card, right? So card elastic, you add weight to it, the length each time increase. In plot a graph and get the graph showing like that. What did he plot on the vertical axis? Say weight is on the horizontal. Him saying him add weights and added more weights, and then what would also be increasing on the y-axis. Right? Let's see. The key word here is elastic, right? So elastic. When you talk about elastic, it's always, well, let's see. It's always gonna be force or weight or load versus whatever going to cause a change, going to cause the length or extension. Any one of those words can be used here. So now this is where they're testing to see if you really know what you're doing here. They give you weight already because they know say, all right, students will know say, because you measure the length of the card here, and add weights to it. So therefore weights is increasing, weights is going up. So that's a giveaway here. But as you add weights to the elastic card, the card is expected to what? To stretch, no so? And if it stretches, the length will increase. So what would he put on the vertical axis? Is it the measured length or the original length? The original length will always be the same. Whatever length the card was, so it can be this. So this will be out. Whatever is on this axis must be changing. So is the measured length changing? Is the measured length plus the original length changing? What is it? Is it the measured length minus the original length? So this is actually a close question, but it's easy to tell the difference between C and D though, and it is a possibility. But let's look at this. If the length is increasing, well, it actually starts from 0 here. So if the length is increasing, then he would be adding. So therefore, it can be minus. Well, let's see. Measure length minus original length. This actually, if the original length was 0 and the measure length keep on increasing, this basically would eliminate C, you know. In fact, A is the answer though, but I was trying to see the closeness here. Measure length still, that's the thing. Because guess what? Him add weight to it. So if him adding weight to it, him have to go measure the how much it stretch, how much the length increase by. So it would be the measured length. Since that him start from 0, it doesn't matter what length it was before, really. So that will just eliminate this and this. So therefore, A is the answer. A 5. All right. Simply because him start at 0. If he started if he did measure the length of the string of the elastic card before, then he wouldn't start from 0. That graph would look kind of like what we got. If we go back to our graph in the previous class, I want to show you something. Actually, plot the graph. Which graph it was? If you realize that this graph here didn't start at 0 because he actually measured the increase in the length of the string, so of the card, whatever I use here. So when it don't start from 0, it means that the original length is included. In this case, it is actually subtracted from what is there. Subtract means to go back, and that's why you draw this dotted line, go back to the original length. All right, so that's why you know. But him start from 0. Now I remember somebody was asking a question in this class where if they could start from 0, and I was saying that you could start from 0 with this graph, but the accuracy would be off. The only way you start from 0 is if you're gonna ignore the original length, right, of the object, because it must have a length before. So let's go back to this then. So therefore, measured length, this is what going to increase. So therefore, the answer is measured length. That should go here. All right. So that is it. All right, guys. So this will just take care of Hooke's law. Remember that. And the only reason why we're spending time here is that because we just didn't do enough of this in regular time. So we even touch a little bit on moments, turning forces. So as I say, CXE can easily combine these two questions into one, and feeling stronger, that's what they're doing along with the graph there. All right. Now, this is especially 13 to 15 magnetic forces. This is a big deal. This could be because potentially 30 marks. It's big. It's big. 30 out of 100 is 30%. First question is 25. So if you can do the first question good and do the sure questions, 30 marks, you will actually pass the paper for this exam knowing electricity and knowing how to do graphs well. Plus a little of the Hooke's law stuff that we're doing there. That will make you pass the paper and ultimately pass the exam. So the key is here. No, you want these marks. This is where the grade 1 is hiding, because these things that I already circled, it's just revision for you guys. All right. But these that I don't circle, 30 marks are hiding here. 25 marks hiding in the first 3. That's 55 marks, guys. 55 marks. So guys, what you think about that? What's your plan? What's going through your mind now?
So good, sir.
So good.
Book long more, mostly. So you can get your marks, yeah.
Yeah, I would say, guys, you start by knowing what these topics are. You start by learning the definition. What is alternating current? What is resistance? What is magnetic force? What's an electromagnetic force? And what is a motor? Answer those questions. That's a start, because that's what is going to, the questions will build on that. So all right. So does anybody have a clue as to what 11 to 15 what the definitions are for 11 to 15 here? All right. Nobody has any idea what an alternating current is? Because it's coming in.
Alternating current, what, sir?
It's here.
It's current only flow one way, sir.
That's
Yeah,
an alternating current.
alternating. Sir, I think I mix it with something else.
Yeah, well, think about it. Because we have to get to the root of this. What on earth is an alternating current? All right. So yeah,
So I think that one day reverse the direction because DC go one direction. I think the alternating current go in next way.
oh,
Two ways you can go, sir. I think that two ways you can go.
2 ways you
Is
can
that
go.
one?
All
Yeah.
right. 2 way you can go. All right.
You can go forth and can go back.
All
Like
right.
you can go.
Yeah, but all right, good. So good. We have to put it. So therefore we need to add that to it, yeah, to a stack here. All right. Anybody seeing this? Okay. So here's what we're looking for. Now, all right. First of all, current is the flow of charge. So current is actually movement of electrons in a material. All right. Usually what that material is called a conductor. All right. So in fact, they say they're defining voltage here, but the voltage is what causes the current. So the AC current now. So in AC current, the electrons change them direction. And as it notice the current actually follow the voltage, So if you know if you know what AC voltage is, the current now would follow that. So let's see now. And AC voltage, that's what alternating mean. Well, AC voltage is defined as voltage that periodically reverses polarity. Polarity means direction of flow, really. So direction of flow, yeah, and will cause current to flow in the reverse direction. So reverse the polarity. And what this mean now, because this is going towards the next thing, which is how AC current is produced. AC current is produced from magnets, guys. So with a magnet, you know that a magnet has two parts. All right. Anybody know the names of the two parts of a magnet?
North Pole and South Pole.
Oh, the Chanel. All right. Very good. Yeah. So so North Pole and South Pole. So now, so the question is now, what does magnets have to do with alternating current? The answer is that the answer is that I'm going to show you this image here. All right, let me just show you this image. All right. Here we go. We have, all right. All right, let's take it even simpler than that. So it's yeah, there we go. All right, we so you said North and South Pole, which is indeed correct. But there's something we have to understand with those poles that we talk about. All right, these poles are different. But then, what if you were asked to tell the difference between the North and the South Pole? What's the difference between the North and the South Pole? All right. Let's you notice all the arrows I'm pointing there.
Yes, sir. Not
Yes,
or not
sir.
repel, sir.
Okay, so this is our repulsion. Using the right word here. This is actually repulsion. And then of course we have attraction here with the opposite poles here. So then we have a attraction there. And so the issue is then, guys, is that whenever if we were to walk around a magnet, we'll feel a different type of, it's going to have a different feeling. We're going to experience a different force depending on which part of the magnet we are located. So that summarizes the entire thing we're talking about here. All right. So opposite poles attract, same poles repel. All right. Now, all right. How does that apply to current? Well, let's show you this image. All right. And this is something that CSEC does constantly ask about. This guy comes up a lot in this topic. Michael Faraday. All right. So this guy discovered that, magnetism can cause a current. And this term used, induction. All right. What happens here? He actually created a system where you connect some wires in something called a coil, basically looking like a spring, but and in the opening he put a magnet inside there, and he realized that when he moved the magnet, like the arrow is pointing, well, so this would be the south pole, by the way, and of course this would be the north pole. He realized that when he moved this magnet through this opening here that he created with wire, this arrow here, this device measures the tiny current that is produced in the wire. So he moved the magnet in this space, and he realized that it caused the electrons in this material here, this black material, to move in a certain direction. When he move it down, it move one direction. When you move it up, or let's say left or right, then if you move it left, it deflected this way. When you move it right, it moved this way. All right. No, the scenario here is that if a magnet is moved back and forth through a coil of wire, the current can be made to flow through the wire. All right. This is the idea behind electric generators and transformers. So electric generators, and this is your first understanding here of how alternating current is produced. A generator converts mechanical energy all right, and this is by magnetism, but converts mechanical energy to electrical energy. All right, via magnets. And so that's his whole this is actually AC current now we're talking about here. Why is AC? Because you have to build something that can cause to keep current flowing here, because the magnet is what causing it. You're going to have to keep this thing moving back and forth. So notice that you can't have a man just doing that to make current flow through wire, so we can get it to you. So they find something that can either move up and down or forward and backward through a coil of wire, and it keeps on producing current. But the problem is that the current will change direction. So because we're using a magnet and there's a north and a south pole, each pole have different energy, then put it that way, different force. All right. So that is where the whole alternating current come from. Right? So if it's close to the South Pole, then the electron's going to move one way. If it's close to the North Pole, then it's going to move the opposite direction. All right. So I'm going to leave you with that. We're going to go more into this, but that is the concept behind alternating current, guys. All right. So as we say, the periodically reverses polarity. And this is telling you about the North and the South Pole. All right. And it causes current to flow in reverse direction. All right. Any questions here, guys?
No, sir.
No,
All right. All right. So for the AC voltage, just remember the AC voltage is actually produced in a generator. Let me just underline here. This is caused by a generator. Now, for the DC current now, this is actually produced in a battery. So for throughout those topics that we're going to look at, we have to have a good idea between the two devices. The two devices that will be producing our current would either be a battery or a generator. All right. So we're going to look more at that later on. All right. Now, yeah, so I'm going to leave you with that. And there's also, and by the way, as it relates to the physics labs, there are finished, and I think I've gotten from most persons. I think I saw Dwayne, and then there's Deborah and Janari, believer, saw some from, and then Kaylee as well. All right, so just 4 persons here. Didn't hear Giovanni today. Giovanni, are you here? You still there?
Yes, sir. I talked like 3 times.
Oh Lord. Oh, Mr. Viceman. Oh, good. All right, well, all right, let's check in. All right. Kaylee, are you there? Kayla? See? Gone for break. All right. Michaela? Michaela, are you there?
Yes, sir.
Okay. It's good. All right. Don't sound like you're running from far place. All right. It's still there. And Shanta is still there.
Yes, sir.
Okay, good. All right. So, all right. I'm hearing. All right. So there's just 9 persons now. So people get knocked off because of internet. All right, guys. We're going to leave it here. But remember, this is where we're going to continue when we meet again. We just look at 11. We just get a little touch of 11. But remember that the 11th topic and the 13th topic and the 14th, they are all related. So this sound like is a really big boy question them are saying here. That they are closely related. So them can go deep here, and some whole heap of CSEC questions can test your knowledge here. So I actually just compiled some questions, but I'm not going to release them to you yet. Maybe next class we can look at those questions and we'll see how we can answer them. All right, but we just need to know the basics. Just start by learning the definitions for these things, and then we take it from there. All right, guys. So I will see you.
Sir,
Yes, go ahead, Santai.
is Holloway, sir.
Oh, Giovanni, yes.
Are you going to have face-to-face class?
If I'm gonna have face-to-face class. Well, you know, possibility is very, it's likely. Face-to-face class is very likely. I'm gonna have to confirm with Miss Cohn and see if it's possible, because I think other person
Okay,
sharing
sir.
the place. But
Sir?
yes,
So
yes,
you know,
Amar.
sir, I never know you made songs, sir.
Oh, I never know that either. Where you find out that?
Sir, my mommy showed me, sir.
Oh, yeah.
Same, sir.
Yeah, Shantai, you too. Oh,
Yes, sir.
you're a musician, Shantai. You make songs too.
No, sir.
Oh,
My
okay.
mom just showed me.
Yeah, yeah, that's the roots, guys. Even before I went into teaching, that's what I wanted to do. But then, your parents say get a career and stop the foolishness, and then here I am teaching you guys. So yeah, but I haven't forgotten the roots though. So that's it. But then yeah, usually when I just started teaching, I usually make songs about these physics things. But I stopped doing that now because I get old now, so I can't continue. But then yeah, there are some songs all about on YouTube and all over the place. So yeah, any topic you can think. I think I've made a song about most topics here. But it's just that them last somewhere. So from time to time I might post them. So they are around. But yeah, everybody have them hobby, So that's how it is. But that's what it is, guys. So yeah, that's it. But we'll see each other, guys, and that would be on Thursday, right?
Yes, sir.
Yeah. Yeah, all right. So guys, as we say, take care of yourself and stay safe. And as we say, go over your notes, guys. Please go over the material. When I get the chance, I'm gonna send that paper in the group. The paper will work tonight. All right, so
Okay, sir.
yeah. All right, guys. So take care.
Yes, sir.
All right, cool.
Yes, sir. Same to you, sir.
All right.